Good morning. Today we are going to be continuing what we actually did the other day. We are going to be looking at issues associated with spurious regression. Also know how to solve problems associated with spurious regression. So I'll beg you to stay tuned to my channel this morning as I expose to you how spurious regressions are being detected. So basically, in time series studies or in econometric studies, people find it very easy to go into estimation without knowing that not all estimated results are good for policy making. Basically, in OLX estimation, just like the one I did the other time, there is always an issue associated with the arrow square and the WRC statistics, as well as the signs and the significant disposition of the coefficients. So today I'm going to expose to you what spurious regression means and how it will be detected in a regression result. So basically, you know that time series data are trended and non-stationary in many cases, and that leads to what they call spurious regression. And econometricians, in the process of getting things correct, try to achieve or elicit higher arrow squares and very high value for the t-statistics ratios. And these decisions, in most of the time, are even taken when the variables in questions are not related. Related. So the word spurious regression is a statistical model that shows misleading statistical evidence of a linear relationship. And when I'm talking about linear relationship, I'm referring to relationship between one variable or the other, or one variable and others. So whenever time there is no linear relationship between the variables you are estimating, there's always a tendency of having issues that has to do with spurious regression. So basically, to identify spurious regression in any econometric result is to look out for most of the items I have listed here. Aside the use of graphs that look similar, the major way to actually identify the presence of spurious regression in a result that looks even very, very fascinating is to look at for the arrow square. Whenever time the arrow square of your estimation, especially when you are dealing with a single equation model, when your arrow square is higher than your WRC statistics, then there is an evidence of the spurious regression in your result, because you must check out for the value of the arrow square. Whenever time the value of this arrow square is greater than the value of the WRC statistics, then there is an evidence of a suspicion of spurious regression in the result. Then secondly, the arrow square, whenever time this arrow square tends towards 1 or unity, it then means that there's also an evidence of spuriosity in your regression, what some people call a nonsense regression. So when we say that arrow square tends towards unity or 1, we are referring to the fact that the arrow square is above 90%. When arrow square is above 90%, then there is an evidence that the regression result may be spurious. Then basically, the WRC statistics has a normal acceptable range of 1.50 and 2.50. So whenever time your WRC statistics is above 2.50, then there is also an evidence of first order autocorrelation, which is also signifies that there is an issue. Or when your WRC statistics falls below 1.50, there is also suspicion of first order autocorrelation in the negative direction, and that's an evidence of suspicion of spuriosity in the regression. So basically, aside these two major issues, or aside the use of arrow square and the WRC statistics, we also have issues with the significant disposition of the coefficient estimated so far. Whenever time the coefficient, the estimated majority of the coefficient are not statistically significant, it also raises more questions on the side of the researcher to ask why you will be accepting a result with a poor significant nature of the coefficients. So it's actually expected or acceptable whenever time majority of the coefficients are statistically significant. So finally, the t statistics, or what we call the t ratio, should also not be more than 4. Whenever time the t ratios of the results are overbloated, is also an evidence that there may be a suspicion of a spurious regression. So basically, let me go to a UV portal to actually explain to you what I am trying to explain or what I've been saying so far. So if I want to go to my YouTube top EView portal, I actually go back to what I did the other time. This is my EView. I open my EView. I open my EView. This is my EView. Import my series. This morning I want to import my series from file. I import my series from file. I move to this area. I actually want to access the desktop. I move to this area. I locate my Excel sheet. I locate my Excel sheet. I want to work on market capitalization and economic growth. I locate my Excel sheet. Then I load my data appropriately. Once the data is being loaded appropriately, my start date is 1981. That is my start date. 1981 is my start date. I click finish. My data is now officially loaded in the EView work sheet for estimation. So I want to assume that this is the range I am working with. This is the range I am working with. This is the range I am working with. So to estimate an ordinary OLX, remember in my first class I told you that for you to perform an OLX, it is expected that the time series data you are using for the work or for the estimations were all stationary at level. And whenever time your time series data were stationary at level, it means that the variables that are reverting to it means, or it means that they became integrated at their stationary level stage. So whenever time you have time series data that do not have a problem, then at that level you are going to use them for a long run test, because a long run test or an OLS estimation require that the time series data will be stationary at level. And when a time series data is stationary at level, it then means that that particular time series data do not have a unit truth problem. So let's assume, without considering, that the data we are using this morning are detrended and the data do not have a unit truth problem. At that level, we can be able to proceed. So if you go to quick, you go to estimate equation. Let's assume we are looking at how stock market variables affect economic growth in Nigeria, just like what we did the other time. Then we now log the economic growth variable, which is ROGDP, just like what we are seeing here. Economic growth is rosy with ROGDP. We give a space. We log the market capitalization index, which is also here because it's a value. That's why we are logging it. We give a space. We log the number of deals in the market. We give a space. We log the values of deals in the market. We give a space again. VTrans. We give a space again. Then we also include interest rates in the model. We include interest rate in the model. We'll give a space. Because it's an OLX estimation, we are not going to change anything in the model or the sample or in the option. Everything will remain the same because it's a long run test and OLS test. I think this is one of the most simplest tests to be done. Then once you hit the OK button, you are going to get a result that looks like this. So I will copy this result neatly to my Word file for easy interpretation. So this is the result of the OLX estimated. So let me explain to you the presence or absence of a spurious regression using this result. Okay, in this result, recall that I told you that for you to identify spurious regression, your attention will go to the arrow square, and the double Watson statistics. Your attention will go to arrow square and the double Watson statistics, as well as the significant nature of the coefficient. I'm highlighting the areas I want to use for the interpretation. So these are the areas I explained to you initially, so we are going to look at them one after the other. This regression was just done today using least square estimation procedure. The dependent variable is ROGDP, done today. This is the time 8:12 a.m. So actually the sample size has adjusted from 1985 to 2020, included observation is 36. So actually these are my independent variables. These are my independent variables, also called the explanatory variables, and the variables that modernizes the ROGDP variable. So let's look at the double Watson, the arrow square. The arrow square we are having here is 1.04, and this arrow square is above 1. This arrow square is very, very high and is in negative direction. And this arrow square in absolute term is greater than the double Watson statistics. And this is an evidence of a spurious regression. Why is it an evidence of a spurious regression? Because the arrow square value of negative 1.041128 indicates that the arrow square is above 1. And since this arrow square is above 1, it shows that this particular regression is a nonsense regression, is a spurious regression. Then secondly, the double Watson statistics. We have a range of 1.50 and 2.50. Whenever time the double Watson statistics falls below or above the range of 1.50 or 2.50, it also shows that the regression is spurious. In this case, we have a double Watson statistics of 0.465819, which shows that the regression is spurious. Why is it spurious? It's spurious because the double Watson statistics falls lower than the accepted range. Then, thirdly, majority of the coefficients. Yes, we have two of the coefficients that are statistically significant, but the significant disposition of this coefficient do not mean that we will accept the result when the arrow square and the double Watson statistics were giving us evidence of spuriosity. Then, fourthly, looking at the t statistics value, we have a situation where we are experiencing 4.7, and 4.7 t statistics actually shows that there is also an evidence of spuriosity in the regression. So basically, the other day I told you that the coefficient divided by the standard error, you get the t statistics. I also told you that there is a negative relationship between the t statistics and the probability value. Whenever time the t statistics goes up, the p value goes down. When the p value goes up, the t statistics goes down. So brother, this is how to actually explain or identify or indicate the presence of spurious regression in your work. Not all estimation will be accepted. Whenever time you are privileged to run an OLS regression, please try to look at to these particular issues or items I identified this morning. If these items are not well placed, please do not use such a result for any meaningful explanation or interpretation for any policy made on such basis that will be exercised in futility. Thank you for staying out. In my next video, I'm going to teach you how to correct or how to solve problems related to spurious regression. Thank you and God bless you.